Hi all, I'm Pushpa and welcome to my channel Tech Talks with Pushpa. Today's topic is JDK, JRE and JVM. When you're learning a programming language, you need to know how that programming language actually works. Once you write the code, you need to understand how that programming language executes that code. When it comes to Java, we frequently hear these acronyms JDK, JRE and JVM. But most of us don't know how exactly this works. In this video, let's cover it in a detailed way. See, this is the hierarchy of JDK, JRE and JVM. JDK is a superset of JRE and JVM. Inside JDK, we have JRE and some development tools. Inside JRE, we have JVM and the set of libraries and the files which are required for a JVM. Let's see it one by one. Now, before going to that one, let's understand how Java compilation process works. Suppose we are having three classes, c1.java, c2.java and c3.java. In c1.java, I am writing PSVM, which is public static void main. Inside this main, we are using two methods, m1 and m2, where this m1 is implemented in c2.java and this m2 is implemented in c3. Once we wrote this all c1, c2, c3.javas, we are compiling this one. Once we give .java files to compiler, our compiler will give bytecode, which is like .class files. For c1, c2, c3, we are getting a .class files of c1.class, c2.class and c3.class. Now see what happens, how we execute this .class files. In our memory RAM, we have JVM. In JVM, we have a class loader which loads all these .class files into the RAM. Once these .class files got loaded, in JVM we have a bytecode verifier. What bytecode verifier does, it verifies all the bytecodes of C1, C2 and C3 .class files to check all the security aspects of this bytecode. Once the bytecode got verified, we have an execution engine in our JVM which executes this .class files into the machine code. This is what we call as a JIT code generator. JIT code means just-in-time code generator. Here in Java, we are converting all this .class files to machine code just-in-time. That is why Java takes more time to compile your code when compared to other programming languages. It's Java virtual machine. Why we call it as a virtual machine? Because there is no physical existence of this virtual machine. What JVM does is, JVM gives the specifications for the Java runtime environment. Specifications means set of rules how a bytecode need to be executed in a runtime environment. See, whatsoever programming language code you write and you convert it into a bytecode, and if you give it to JVM, it executes that code. This is what JVM is. Now, inside a JRE, we are having a JVM. What is JRE? It's a runtime environment. Runtime environment means it has some software tools which we use for developing of a Java application. It is having JVM and a set of some libraries and some other files which are required for this JVM specifications. Means the way in which our code need to be executed. The bytecode need to be executed. See, this is JRE. Inside JRE, we are having a JVM and other libraries which supports a JVM to execute your code. Now let's go to the superset, which is JDK. It's a Java development kit. This JDK contains whole JRE plus some development tools. And this is a physical existence. We have JDK and JRE as a physical existence, where JVM is a virtual machine. In JDK, what we contain? We contain JRE plus development tools. What you mean by development tools? We have an interpreter, we have a compiler, we have a document generator, we have a jar file converter and everything. If you see, this is the JDK. Inside JDK, we are having whole JRE plus this development tools of interpreter, compiler, jar files and the Java docs one. And inside JRE, we are having a JVM and the libraries and files which supports this JVM to execute a bytecode to machine code. See, JDK is a superset which contains JRE is a subset of JDK and JVM is the subset of JRE. Now if you see this JDK, JRE and JVM are platform dependent. I'm not confusing you because this JDK, JRE, JVM are platform dependent. Means JDK, JRE and JVM of Windows are separate one. This JDK, JRE and JVM of Ubuntu is separate, and for the Mac they are separate. But the code but the Java code you write is a platform independent one. What I mean is, like, in Windows, you write your Java code, like some p1.class, some p1.java class. Once you wrote this code and you compile it, you get p1.class file. From p1.java to p1.class file the compiler will give. The compiler which is present in the JDK of your Windows system. But you can deploy this .class file, this p1.class file in any system. Means in any Ubuntu system or in the Mac system. Now that the JVM of that Mac system executes this .class file, you created this class in Windows system, but you deployed this .class file of this p1.java into Mac 1. The JVM of that Mac 1 will execute your .class files and provides the output. That is why the JDK JRE JVM are the platform dependent, but the Java code you write is a platform independent one. I hope now you're clear with this concept and the hierarchy of this one and how Java code compiles. Happy coding. See you in the next video. If you like the content, please like, share and subscribe to this channel.